So digitizing pathology, this is what we do at PathologyWatch. I'm gonna take you through a day in the life of a specimen to help you better understand what we do in our lab. So at the clinic, when you go to your dermatologist and you have a mole or something that looks suspicious and you wanna get it removed, you'd make your appointment, you'd go in and see that doctor, and your doctor would either surgically remove that. If it's larger, it'd be an excision. If it's smaller, a biopsy. And that biopsy or the spot that's in question is removed. That spot is a specimen. So as you can see in our bottle, the arrow is pointing to that little specimen. The bottle is full of formalin. Formalin is what fixes the tissue, so it helps that tissue remain intact during transport. This bottle and the patient paperwork, which is called the requisition, are sent to a PathologyWatch lab. When it arrives at the lab, the specimen in the bottle and the requisition, they come in a biohazard bag. We open up the biohazard bag, we remove the requisition, open it up, and enter in the patient information into our LIS, which is our laboratory information system. And the requisition gets scanned and uploaded to that patient record as well. And then the bottle gets moved to the grossing station. So grossing meaning a larger portion is made into a smaller portion. Just like with your paycheck, when it comes, you get the gross, but then you only really get the net. So at grossing, we only use the parts of that specimen that are needed. If it's small, we use it all. That all happens at grossing. So the specimen is inked to help with the orientation once it's digitized. The specimen's inked, cut into pieces, and those pieces are placed in a cassette, as you can see here. If it's a larger specimen, it needs multiple cassettes. If it's a smaller specimen, the one piece or several pieces can be placed in one cassette. After grossing, those cassettes, which contain the pieces of tissue, get placed into a processing machine. The processor is what dehydrates the tissue. So our body is full of water, and slicing water into thin slices does not work very well. It's like trying to cut cottage cheese into a nicely thin slice. It's very watery. So the processing machine uses alcohol to remove the water, so dehydrates it, and then it infiltrates those spaces that once had water with wax. Wax is a lot easier to cut, so that's why we do this. After the processing happens, we remove the cassettes and open the lid. Inside the cassette are the pieces of tissue that were processed and infiltrated with wax. Those pieces are carefully and precisely placed inside a mold. This is a metal mold. The mold is then filled with wax. I guess it would be the bottom part, or the lid of the cassette is then placed on top of the mold and becomes the base for what we call a block. So those wax-filled pieces of tissue are then covered with more wax, and it creates a block, or you can think like a block of cheese. A block of cheese is a whole lot easier to cut than watery cottage cheese. And this is now a block which we commonly use throughout the rest of the process. The block then gets moved to the cutting or sectioning station. This is a microtome, and the block is placed right here in the chuck head. And the chuck head is connected to a lever or an arm, and when that wheel is rotated, the wheel moves this chuck head containing the block up and down, and this is a razor blade. So the block is moved up and down along that razor blade and creates a ribbon or a bunch of slices of cheese stuck together. And inside each of those slices is the tissue inside the block. So each slice that comes off of this is called a section, and we section our tissue at 4 microns. Unless it's like a lipoma or something that's very tricky, then we can go up to 5 microns. That's our standard. From there, this tissue is brought over to the water bath, and because it's wax, it floats on top of the water. We can see that here, the tissue is floating on top of the water bath, and this is where it becomes a slide. So a blank labeled slide is used to get underneath this section, and then we scoop up from underneath the section, and the the piece of floating wax. Those sections stick to our glass slide. From there, we put the slides in a rack and place the racks on a stainer. The stainer is used to stain our routine stains, which is H&E, hematoxylin, and eosin. And the stain helps the pathologist see the different cell types within the tissue. And then after that comes cover slipping. So in order to protect that tissue so that if it gets bumped or touched, it doesn't rub the tissue off the glass, we cover slip it. So we put a cover glass or a tape cover slip on top of the tissue to protect it and keep it nice. From there, after cover slipping, we dry this. We dry this because each slide, whether it's tape cover slip or cover slipped with glass and mountant, it contains that xylene, and xylene keeps things loose and fluid. So we want to make sure that the mountant is hardened and the tape cover slip resin is solidified so that no movement happens. This is especially necessary when using a digital scanner because nothing wet or loose can go inside the scanner or can ruin the hardware components. The next step is scanning. Scanning is what takes those slides and the tissue on the slide and turns it into a digital image. So the slides are scanned using an objective. We prefer the 3D Histotech scanners. They're the best we've found on the market. This is a P250 3DH scanner, which holds up to 250 slides at a time. And then this is a P1000 scanner that holds up to 1000 slides at a time. In order to scan a slide, you have to have the correct profiles. The profile tells the scanner how you want the tissue on the slide scanned properly. So you want to make sure that the tissue is covered in a scan mask. So once those proper adjustments are made, this is the P250 software and the previous one was the P1000 software. Once those adjustments are made, the scanning takes place and the file gets saved onto a local drive onto the computer, is connected to the scanner. And then each scanner has a watch folder. So this file gets dropped into the watch folder, and then the PathologyWatch uploader, which is on because you can see the PathologyWatch icon right here on the Windows taskbar. It watches this folder. Anytime a file drops in here, it then uploads the file or that digital image to the PathologyWatch viewer. And that slide then is digital. You can see here on the viewer the clinical history, the source, the gross description. You can also see the diagnosis and any orders that were placed on this for additional staining that needs to be done. The patient information is found here. The pathologist is also listed here on the viewer. So much information can be found here. So this is the scanned image in the middle. This image in the lower right-hand corner is just the preview or a macro image. It's just like an image that you'd take with your cell phone. Take a picture of what you see on the label and take a picture of what you see on the slide, but you cannot zoom in or out on this image. The center image is the one that you can zoom in and out on. And this lower left-hand image is just a map to show where on the slide you're located. These thumbnails at the very lower left-hand corner show you the different slides that are in this case. So this particular case had 7 cassettes or 7 blocks and A1 through A7. So that specimen came from the same location on that patient's body. It was the skin from the right forearm, but it was a larger piece, so it needed to be cut into into 7 different cassettes, which those cassettes were turned into 7 different blocks. So we're looking here at the 7th block, A7. And when zooming in, you can see the cell types are purple. This is that hematoxylin we talked about at the staining step. Hematoxylin stains the epidermis, the cells within the epidermis purple, and then the connective tissue and the deeper tissue is stained pink with a eosin. And that is so fascinating. This is the diagnosis for this slide tissue. And there you have it. That's the day in the life of the specimen, from the dermatologist clinic to the lab and then on to the pathologist who reads and diagnoses the tissue. And then from here, a report in this upper right hand corner, a report is generated, and that report gets sent electronically back to the dermatologist, where the dermatologist can read and tell the patient the next steps to treat the lesion.